Let's simplify this expression. We have this trinomial that can be factored. We have 2x plus 3 times x minus 5 is the factored form on top. And we factor out the GCF 2x. This multiplied by x minus 5 becomes the bottom here. And let's change this division symbol to multiplication and flip the top and bottom. The 6 in the denominator now goes on the numerator, and this here on the top goes on the bottom. And it also factors to be 2x times 2x plus minus 3. We use difference of squares. And this here is on the numerator. So let's factor out a negative 1 here. So let's multiply by negative 1 and pull out the 2x minus 3. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. Now the reason why we pulled out a negative 1 is so that these 2x minus 3's cancel. We also have x minus 5 canceling, and so does 2x plus 3 diagonally. What's remaining? We have negative 1 times 6 is negative 6 on top, and we have 2x on the bottom here. This simplifies to be negative 3 over x. Let's simplify this rational expression. On the numerator, we can factor. We have 2a plus 1 times 4a minus 3 becomes the numerator. As for the denominator, we factor using difference of squares. A plus 1, a minus 1. Now this division symbol can be changed to multiplication if we flip the top and bottom. So let's focus on the bottom, 2a minus 2, which has a GCF of 2. 2 times a is 2a, and 2 times negative 1 is negative 2. And now let's factor the top, which ends up on the bottom. We have 2a plus 1. A minus 2 is the factored form, trinomial factoring. We'll switch this division symbol to multiplication, and in the same way, flip the denominator and numerator. A plus 1, and we have 3 minus 4a. If you pay careful attention, notice how 3 minus 4a seems similar to 4a minus 3. We'll call these fraternal twins. Because if we rewrite this as negative 4a minus 3 with brackets, we have an equivalent expression. Negative 1 times 4a is negative 4a, and negative times negative is positive 3. And by doing so, we have the same factor up here, which can cancel out with this factor here, leaving only negative 1 on the denominator. We have 2a plus 1 up here that cancels with this over here, and we have a minus 1 canceling with a minus 1 here. We also have the factor a plus 1 canceling with a plus 1 down here. So a lot of factors canceled, and the only number left on the numerator is a 2. We have a minus 2 on the denominator, and we have negative 1 as well on the denominator. We have 2 divided by negative 1 is negative 2, and on the denominator we have a minus 2. So as for the non-permissible values, yes, we're dividing by 2 here, so we say a equals 2 is a non-permissible value. We state this in the affirmative, but there's also other non-permissible values. Even for a split second, if we're dividing by 0, we have a problem. So let's focus on the original question here, and this a squared minus 1 split off to become a plus 1, a minus 1. So we know that a equals plus minus 1 are also non-permissible values. We had 2a minus 2. When we factor it, 2a minus 1 is the denominator. So we already said that a equals 1 is a non-permissible value. Furthermore, we have a plus 1 can't be 0. So we already took care of that. A equals plus minus 1 are our NPVs. When the division statement becomes a multiplication statement and we flip the top and bottom, we have additional NPVs. Let's focus on the 2a plus 1. 2a plus 1 equals 0 causes a vertical asymptotes. So we have 2a equals negative 1, and we get negative 1/2 as another NPV. Finally, for a moment, we have a denominator 3 minus 4a. 3 minus 4a equals 0. So 4a equals 3. A equals 3 over 4 is yet another NPV. So we found all the NPVs by considering the cases where we're dividing by 0, both for the division statement as well as the multiplication statement. And it's good to know that the NPVs are in the affirmative with an equal sign, whereas the domain, we just change all the NPVs to not equals to sign.